everyone. So today we're looking at Leetcode number 702, search in a sorted array of unknown size. Okay, so this question is basically we have a sorted array, but we don't know what the upper bound is. We don't know how big this array is, and so we need to search through this array and see if the target is in there. And if it is, we're going to return the index. So let's just kind of review over the prompt. Given an integer array sorted in ascending order, write a function to search target in nums. If target exists, then return its index, otherwise return -1. However, the array size is unknown to you. You may only access the array through ArrayReader interface, where ArrayReader.getK returns the element of the array at the index k, 0 index, okay? And we can assume that all integers in the array will be less than 10,000, and if you access the array out of bounds, it will return this very large number. Okay, so here we have an input array, -1, 0, and so forth, and our target is 9. We don't know what the upper bound of this array is, so there would be two ways we could look at this. We could scan this linearly and just try to go through each one. However, if the element is not in there, we don't know when the array ends, and we can end up with an infinite loop. The issue with doing binary search is that's the other approach we could do this, but we need to know the upper bound. We know the array is sorted, but we don't know what the upper bound is. Okay? So how would we go about solving this? Let's jump over here in the conceptual and think about this. So let's say we have this array. Let's use a different color here. I'll use white. Let's say we have this array and it goes on for length, let's say 5,000, right? Okay, but we don't know what the upper bound is. What we want to do is we want to figure out the range that that target is in. So for example, if the target here was, let's say, 2,500, okay, we know what the lower bound is, we know what the left is, we can start it at 0, okay, and now what we want to do is we want to have a right, and then we want to multiply this right by 2, and then set the left to the right, and then keep on multiplying the right by 2. So what we're essentially doing is we're getting a range from here, then we're getting a range from here, then we're getting a range from here, and so on and so forth until we find the range where our target is in. Okay, so just to kind of reiterate that so it makes a little more sense, let's actually use some numbers here. Let's say we set our right to 1 and our left to 0, okay? And our target is 2,500, and let's just say these numbers are sorted 1 through 5,000, okay? Now, if we say, is the range, is 2,500 in between the right and the left? No, it's not. So then what we can do is we can set left to right, and then right, we can just multiply right by 2. Okay? So right will go from 1 to 2 to 4 to 8 to 16, so on and so forth until it gets above, until right is above the target. Okay, so let's say right gets to 3,000, right? And left is going to be set, so as we go up, this is left and this is right. What we're then going to do is once right is here, we're going to place left there. So now the range we're looking at is between 2 and 4. Okay? When right gets to 8, the range we're looking at is from 4 to 8. When right gets to 16, the range we're looking at is from 8 to 16. Okay? And so on and so forth, and whatever right is at 3,000, the range will look at, the left will be just whatever right was previously, which would be half of that, which would be 1,500. Okay? So that's the idea. And then once we know that range, once we know that our target is in between 1500 and 3000, then we just run binary search on that. That's all we have to do. And so we can get a log n solution. We just run 2 log n passes. One pass is getting the range, would be log n. And then the other pass would be finding the target between that range, which would also be log n, because we know it's sorted. Okay? So it's not too bad. It's not too bad when we think about it that way. We just need to calculate the right and find the range between right and left, and then we just go ahead and run binary search. Okay, and I'll just quickly kind of go over how binary search will work. Let's say our range is right here, like whatever the input is, and we go ahead and we have our left here. Grab this left here. And let's say our right starts out right over here and our target is 9. Okay, so now right is not less than the target. So what are we going to do? We're going to say right times 2. Right is going to equal, well, first we're going to set left to right. Okay, so I'll go ahead and move this left over here. And then we're going to say right is going to equal right times 2. So right will move over there. Okay, so now our range is between 1 and 2. Now we ask, is this right, is it less than the target? It is. So what are we going to do? We're going to multiply right by 2, which is going to equal 4. And we're going to set that left to whatever right was previously. So now the range is between indice 2 and 4. Okay? And now we ask, is right less than, not less than but equal to, but is it less than the target? It is not less than. It's equal to, but it's not less than. So we're going to say right times 2, the indice times 2, which is going to be 8. Okay, so we'll just go ahead and say right here is going to be at 8. Okay, and left is going to equal wherever right was previously. Now we know that our target is in between this range. Okay, our target is 9. And so now all we have to do is go ahead and perform binary search between that range, and we go ahead and get our solution. Now, I'm not going to go over binary search. I'll leave that for a separate video, but you should be familiar with that pattern, binary search. It should just come instantly to you. We'll quickly go over it. What we're going to do is just find the mid. If the target is less than the mid, then we're going to go ahead and move this right over here to mid minus 1, and then we'll set a new mid. If the target is less than mid, we'll set it to mid minus 1. We'll set a new mid, and then the target will equal mid, and we'll get that 9. Okay? And so that is a log n time complexity. Both ways, we're doing one log n pass to get the range, and then we're doing another log n pass to go ahead and get the actual target. Okay, which is pretty good, So let's just go ahead and write our time and space complexity here. Our time will be O of log n. And our space complexity, we're not creating any new space. We're not storing these numbers anywhere. We're creating some variables, but the space is not increasing relative to the size of the input, so our space complexity for this will be constant. Which is really good. And the big clue on this is that anytime you see sorted array, you should immediately think binary search. Can we run binary search on this if there's some sort of search that we need to do and the input is sorted? Okay, so let's just go ahead and jump into this code. Let me move this down a little bit so we have some space. Okay, and so what we're going to do is we're going to set our left to 0 and our right to 1. Okay, and so now what we're going to do is we're gonna first figure out where is the range. So while reader, which is this method here, so we'll do reader.get right. If it is less than target, what do we want to do? We want to set left to right, and right is going to equal right times 2. So that'll keep on running until we get that upper bound on right. Okay. Now what do we want to do? We just want to perform binary search. So we just say while left is less than or equal to right. We want to get our mid. Let mid equal floor left plus right divided by 2. Got to make sure you have these extra parentheses or you're going to get a bug because it'll do right divided by 2 plus left. So we want to go ahead and do that. And now what do we want to do? First we want to check, does the mid equal, are we at our target? So we can just do a quick if statement here and we can say let reader.get mid equals target. If that's true, then go ahead and just return mid, because we want to return the indice of where our target is, not the actual number. Okay, and now we want to check if reader.get left is less than or equal to target and target is less than reader.get mid. If that's the case, what do we want to do? We just want to update our right, okay, because it's going to be on the right side. So we just say right is going to equal mid minus 1. Else, what do we want to do? We want to shift our left. So left is going to equal mid plus 1. And if we don't find it in there, then we just go ahead and return minus 1. Move this down so you can take a look at that code. Okay, let's go ahead and run this, make sure everything works. Okay, and we're good. I don't know why it does this, 26%. It's you can see here that if you just run it again and it's 80%, you're in the 90th percentile, but it's log n. It's the times complexity is log n, and our space complexity is constant. I think my internet may be a little slow. That's why it's taking longer. You can see here, so 94% runtime and then 80% on space. So that is Leetcode 702, search an assorted array of unknown size. I think the thing you have to think about this is you can easily apply binary search to this. That's not a difficult pattern match, but it's how you get that range, which is this block of code right here, getting this right, thinking of multiplying right by 2 and getting that correct range. So that's something that's a little tricky about this one, but other than that, it's not too bad. Okay, so that's Leetcode 702. I hope you all enjoyed it, and I will see everyone on the next one.